Hey, Jonathan here at TopSaw. This channel, TopSaw, is all things wood from tree work to woodwork. I teach high school woodshop during the week, and I do tree work on the weekends, ideally bringing those logs in to mill them at the school so we have wood to make wood projects. Today I was going to talk about the difference between a random orbital sander and a finish sander, the advantages of each one, the disadvantages, why you would want one or the other. And then I was going to go through why an orbital sander works. They're actually really ingenious. I'll take that one apart on the left and show you how it gets that random action. So before I start, let me just talk a little bit about sandpaper. There's a lot of different types of sandpaper, a lot of discussions on it, but the most common type is aluminum oxide sandpaper, and then the grit difference. So this is a quarter sheet, 4.5 by 5.5. It's a quarter of the full sheet, 9 by 11. This grit right here is 150. This grit right here is 100. This is really pretty coarse. This is kind of like a medium, a coarse medium grit. And what that number means is how many parts of sand there are per square inch. So the lower the number, the bigger the sand particles. The higher the number, the finer the sandpaper. So 100 is really coarse. It'll take off a lot of wood, but scratch the wood up. 150 is kind of a medium, 180 a medium, and about a 220 is kind of a finer sandpaper. It really depends on what sort of projects you're building. If you're building a step stool, 220 is a good grit to finish on. If you're building a picture frame where your eyes are going to be really close and checking the finish of the product, then you probably want to go more all the way up to a 320 or even finer. How sandpaper works is what you're really doing is you're taking these little pieces of sand and you're putting them in between the grains of the wood. So when you go across those grains, you scratch them, but when you go with the grains, if it's fine enough paper, the grains are in between the grains of the wood. Okay. Then let me talk about the two different sanders a little bit. Again, this is a random orbital sander, and as it spins around, there's a random pattern in it because of a cam inside there, which is super cool. If it was just circular, it would spin in a circular fashion, creating circular scratches across the grain. But the randomness of it moves it around in an oscillating way so that you don't see those scratches. This is a finish sander. It's a quarter sheet finish sander, and you fold the paper or you tear the paper out into quarter sheets and you put it on there. Okay. Here's another finish sander. This is an old Black & Decker half sheet finish sander. It's a half sheet because it uses a half sheet of the sandpaper. And this is another orbital. This is a Craftsman random orbital. These are 5-inch sanders. There's really no difference between this one and the DeWalt, except I kind of like the DeWalt brand a little bit more. Seems a little hardier. Okay, the big advantage of the random orbital sander is you could actually sand a lot faster. So the way the sandpaper is held onto the random orbital is Velcro. This one's actually falling apart a little bit here. So it's kind of harder to take that grit off. So there's the pad. It's just a Velcro attachment, and you just peel it on and off. The holes are to get the dust up out of the work area. This pad's worn out. It's from school, so this one's all worn out. I brought it home to replace it. It's really easy to replace. So changing the sandpaper on here is really easy to do and really nice because when you use sandpaper, you got to step all the way through the grit. So you start at a coarse grit like 120, 150. And then you move up to a 180 to remove the scratch marks from that. Then you step up to a 220 to remove the scratch marks from the 180. On the finish sander over here, usually you buy a full sheet of sandpaper that's 9 by 11. You tear that in half to get 4.5 by 11. Tear that in half to get 4.5 by 5.5. So these are usually 4.5 by 5.5. Once you tear them, you undo these clips. And then the paper comes in and out of those things there. So it's not hard to do, but for some reason the students never step up on the finish sander. They won't change the paper out and go to different grits. So changing sandpaper, big advantage for the random orbital because it's Velcro. And that big advantage is you use all of the right grit and go through it. The second is the random orbital goes pretty fast and efficiently, and the finish sander is a little slow. Students hate sanding, but it's really a big part of the project, and it's what gives you a good finish. The good sanding really allows the material to take in whatever way you're going to seal that wood up. So paper's easier on the random orbital than the finish sander. It's also more efficient and faster on the orbital than the finish sander. Easy use, they're both kind of easy to use. Safety wise, they're both kind of equally safety. Probably the biggest danger is playing around with it being plugged in and getting electrocuted. But if you touch them while they're running, it won't cut you. It'll probably take off a top layer of skin, but it won't hurt you. So then why do people have finish sanders? Well, the finish sander does have some advantages. The square base is really nice. If you're trying to sand the bottom shelf of a bookshelf that's fixed, like in here, with that finish sander, you could come right up to the edge and sand, and it goes kind of slow so you don't screw anything up. With an orbital, when you do that, you usually cut a groove with that into the backboard. So that's one advantage the finish sander has over the orbital. The second advantage and disadvantage that the finish sander has is that it goes pretty slow, so you don't take off a lot of wood. That's an advantage because you don't want to start sanding and create a varying different planes of your board or your project. So on the finish sander, you go slow enough and you could check whether you're putting in, dips and valleys. But the disadvantage is it goes slow. So this thing, because it moves just in a little oscillating pattern, you could get right up to edges without damaging a back. It goes slow, so it doesn't create any valleys. And on the orbital, you could take off wood pretty quickly and then step up through the sandpapers. You could get up to an edge, but if there's a backboard, you got to be really conscientious not to mark it up and groove it with this. With that efficiency and the rate of sanding, the other thing you could do too is you could sand right through a plywood in no time, go right through the veneer, and then ruin that whole part. With the finish sander, it's so slow, you don't really do that as often. So that's the primary differences between the two. They both currently have 220 grit on them. It's kind of a fine grit. I'll show you how they both sand. A good way to check how they sand is just use a pencil and mark up a board like that. And then let me turn on this orbital. You can see it took that pencil mark right off pretty quickly. It's a pretty smooth finish, pretty cherry. Here's a finish sander and the same pencil mark. Little bit of pencil mark left right there. A little bit slower, kind of the same finish on both of them. I do move them with the grain always. So you kind of see them next to each other, how different they are. If you only had to buy one, I would buy the random orbital. So you could do your rough sanding and then move up, and also use as a fine sander. So the key is to use the right paper at the right time and not jump from 120 to 220, but to step up through every different grit. So 120, 150, 180, 220. Okay, so that's the big difference between the two. I was going to pull this random orbital apart just to show you how cool it is. So again, this thing's worn out here. Let me see here. The Velcro just attaches to it. I think it's a T20 Torx that'll hold these things on. I'm going to just pause it here and pull it. So I'm going to loosen up these 3 bolts here and pull this Velcro pad off. This isn't very expensive to replace. I think they're like $5 or $10. And you probably get a year or two of full use out of these before you replace them. Let me pull that off. I'm just going to pause it here for a second and pull that off. So there's a Velcro pad. I'll just pull it off. There are the bolts on there. And then this thing, you just get it at your regular home improvement store. When that starts coming apart like that, it's time to replace it. Or when it starts to wear and the Velcro doesn't stick to it. One thing that really wears these things out fast, which are not designed to do, is when students go up on an angle with them. They're really not designed to do that. It put waves in your board as well. They should always be held flat and moved around. Okay, so this is the inside here. And you could see here, this is a circular motor. Right, so this thing is just spinning around, just a regular motor. And then this thing right here is offset. So as this thing circulates around and around, your actual attachment points kind of free spin here in an eccentric center point. So that's where the randomness comes in, and that's what prevents circular grain patterns on there. This is also a T20 Torx. Let me see if I can pull this off. I think I'm going to have to pause here and do that again. So I loosen that bolt up. Let's pull this bolt off. And then this piece comes off the mounting board. That comes off right there. Right? So that's actually circular. But the attachment point is this cam, right? So as this thing spins around, it's off center, and that's what gives it its randomness. So you could see, it's not quite the center spot there. It's just a teeny bit of randomness, but that's what allows this thing on here to spin around in all directions and gives it the ability not to create a circular sanding pattern. Really very, very clever invention. Alright, well hopefully that helped you identify the differences between a random orbital and a finish sander. They both have their place in a shop. If I could only get one, I'd probably get the random orbital. And then also, I just love the inventiveness of how cool these random orbitals are. It was really a very clever idea. Whoever came up with this idea did. So hope you enjoyed the video. Hope you learned a little bit about sanding and tools. If you're in my class, thanks for watching this video. And be gentle on the tools so we can make cool projects. All right. Thank you for watching.